In this video, we're going to continue with our discussion on maximums and minimums. And in particular, we're going to start looking at how to find maximums and minimum values of a given function. To help us do that, we're going to start with this theorem. If f has a local maximum or minimum value at an interior point of C of its domain, and if f prime of C exists, then f prime of C is 0. So what does this tell us? This tells us that if we have a local maximum or a local minimum in an interior point of the domain of a function f, then either the derivative does not exist, or if it does exist, then the derivative is 0. So either the derivative does not exist or the derivative is 0. This leads us to a definition here. And that definition is that an interior point of the domain of a function f where f prime is 0 or undefined is a critical point of f. So it's the definition of a critical point. Now again, what does a critical point do? Well, what is a critical point? Well, first, a critical point is where either the derivative is 0 or the derivative is undefined. And if we have a critical point, then it is possible we have a local maximum or a minimum there. Or moreover, if we have a local max or a local minimum, then it is a critical point. So, if we find all critical points, that reduces where we need to look for maximum and minimum values. Again, not all critical points will be a local max or a local minimum, but if we find a local max or a minimum, it is a critical point. So if we start looking at all of the critical points, that makes our solution a lot simpler. So let's go ahead and do an example then. Example 1. We want to find the local maximums or local minimums, actually, and local minimums of f of x equal to x times x minus 1 times x plus 1. Note, we can think of the picture of this function, which looks like this, and we can see that the local max occurs here and the local minimum occurs here. Well, let's actually find that using calculus, or using our knowledge that we have so far about minimums and maximums. The minimum or the maximum must occur at a critical point. So either when the derivative is 0 or the derivative is undefined. Well, this is a polynomial, so the derivative is defined everywhere. And thus, really, we just want to find when the derivative is 0. Which tells us that we have our horizontal tangent lines there. So that's where we're looking for. All right, to do that, let's go ahead and rewrite f of x. This is x times x squared minus 1, or in other words, x cubed minus x. This tells us our derivative is then 3x squared minus 1. We want to find our critical point, which is when our derivative is 0. So we get 0 is equal to 3x squared minus 1, or 3x squared is equal to 1, which is x squared is equal to 1/3, or x is equal to plus or minus the square root of 1/3. In fact, this tells us we have a local max at, well, this is to the left of the y-intercept, in other words, the x equals 0 line. So the max occurs at negative root 1 over 3. And the local minimum is at x is equal to the positive root 1 over 3. And here is our solution. All right, we have a second example that we want to cover here. And the second example is to find the critical values of g of t equal to the absolute value of 3t minus 4. All right, if we have an absolute value function, this is a piecewise function where we get negative 3t minus 4, and where t is equal or less than something. And what is that equal or less than something? To find that for an absolute value function, you just solve this value in here, inside the absolute value, for 0. So 3t minus 4 is equal to 0. This tells us that 3t is equal to 4, or in other words, t is equal to 4/3. So, when t is equal or less than 4/3, we use the function negative quantity 3t minus 4. And we use the function positive 3t minus 4 when t is greater than 4/3. Okay. With a quick look at this interpretation of our function, when t is less than 4/3, we get that our derivative is negative 3. So the derivative exists and it is not 0, meaning that there is no critical point when t is less than 4/3, meaning that we cannot have a local maximum or a local minimum. So there is no local max or local minimum when t is less than 4/3, and also, in particular, there is no critical value there. Similarly, with t is greater than 4/3, our derivative is 3. So we see that there is no critical point when t is greater than 4/3. So if we have a critical point, it must occur at t equals 4/3. So let's find g prime of 4/3 and see if this derivative is 0 or if the derivative does not exist. Either one will tell us that we have a critical value there. And again, that will be our only critical value. So how do we do this? Well, we find the limit as h goes to 0 of f of 4/3 plus h minus f of 4/3 all over h. But to find a limit like this, we need to find the limit as h approaches 0 from the left and the limit as h approaches 0 from the right. If those are equal, then the limit exists and they are whatever our value is. If they do not equal, then that'll tell us that the limit does not exist, or in other words, the derivative does not exist at that point. So let's find the limit as h goes to 0 from the left of f of 4/3 plus h minus f of 4/3 all over h. If h is just under 0, that tells us 4/3 plus a negative value. This means that our t value in here is just under 4/3. If that is the case, the t value is just under 4/3. That means we use this function. So let's use that function. So this is the limit as h goes to 0 from the left of negative 3 times 4/3 plus h minus 4. All right, we just plugged in 4/3 plus h in for t here. Minus f of 4/3, which is negative of 3 times 4/3 minus 4. All over h. All right, well, what does this end up being? Well, this is the limit as h goes to 0 from the left of, let's see here, negative 3 times 4/3 is a negative 4. Then we get a negative 3 times h, so it's negative 3h. And then we get a negative 4, so this is a positive 4. These two negatives cancel, so this becomes a positive 4 here. And then we get a minus 4 all over h. Okay, these cancel, we end up with limit as h goes to 0 from the left of negative 3h over h, or in other words, negative 3. So our derivative, or sorry, our limit as h approaches 0 from the left is negative 3. And we need to do a similar calculation for the limit as h approaches 0 from the right. Now, if h approaches 0 from the right, we are using this expression because t is just bigger than 4/3, right? If we have a value that's positive here and we add it to 4/3, then this t value is just bigger than 4/3. So this is a positive 3 times 4/3 plus h minus 4 minus positive 3 times 4/3 minus 4 all over h. What is this equal to? Well, 3 times 4/3 is just 4, plus 3h. Oh, sorry, I left off the limit as h goes to 0 from the right. So this is 4, then we factor in, or sorry, distribute in the 3. It's for the h, it's plus 3h. Then we have a minus 4 here. Minus 4 plus 4 all over h. And we get limit as h goes to 0 from the right of, let's see, positive 4, negative 4 cancel, negative 4, positive 4 cancel. We get 3h, positive 3h over h, so in other words, positive 3 as our limit. These do not match, so f prime of 4/3 does not exist. In other words, c equal to 4/3 is a critical point. And that is the only critical point for reasons that we stated earlier. All right. There's actually one final thing to talk about in this video. And that is to find the absolute minimum and absolute maximum of a continuous function f on a finite closed interval we do two things. First is evaluate f at all critical points and endpoints. And then two, the highest value is the maximum, and the lowest value is the minimum. All right. So again, what does this say? This says that if we have a continuous function f, and on, if we have a continuous function f on a closed interval, finite closed interval, then to find the absolute max or minimum of that, we know that it occurs at either one of the critical points or at the end point of this interval. So all we do is we find all of the critical points, and then we evaluate f at those critical points and at the end points. And whatever the highest value is, that must be our absolute maximum. Whatever the minimum value is, that must be our absolute minimum. So we end this video with an example of such a thing. So we're going to find the absolute maximums and minimums of f of x equal to x cubed minus 6x squared plus 5 on the interval -3 to 2. So what do? We need to find the critical points, which are the interior points of this, where the derivative is either 0 or does not exist. This is a continuous function on here, so we can apply that previous statement that we were talking about. It is also, since it is a continuous and differentiable function, we know that the derivative exists everywhere, so we really just need to find the interior points here where the derivative is 0. Alright, well, let's find where this derivative is 0 then. So first, f prime of x is equal to 3x squared minus 12x. We can factor a 3x out of this and get x minus 4. So this tells us that x is equal to 0 or x is equal to positive 4. And these two values will give us let's see here. Yep, these two values will tell us where our derivative is 0. We set that equal to 0, and these two values tell us where that derivative is 0. Okay, well, this is in our interval, -3 to 2, but 4 is not, so we can ignore that. So really, what do we want to do? We want to evaluate f at our critical points and our endpoints. Well, let's do that. This means we need to find f of -3. So that is -3 cubed minus 6 times -3 squared plus 5. All right, this is -27. This is a 9 times a -6. So 9 times -6 is -54 plus 5. This is -81 plus 5 is -76. Okay, f of now 0. Well, f of 0 is really easy. That's just 5. F of positive 2. All right, this is 2 cubed minus 6 times 2 squared plus 5. So this is 8 minus 6 times 4 plus 5. Oops. All right, so 6 times 4 is -24. 8 minus 24 is -16, plus 5 is -11. Okay, now what does this tell us? Well, the minimum value is our absolute minimum. Absolute minimum of -76 at x equals -3. The minimum is -76. Where does it occur? It occurs at x equals -3. And we have an absolute maximum of 5 at x is equal to 0. All right, so here was our minimum value, here was our maximum value, and those told us our absolute minimum and absolute maximum respectively. And that is it for this video.